I've spent the last 3 months improving our RSHN light module, and the improvements are massive. Or tiny from a different perspective. RSHN started off as a fun project feeding into my personal love for lights. The goal was to create a maker-friendly, no-compromise studio lights for my own setup that simply money can't buy, and maybe learn a thing or two about manufacturing in the process. So if you haven't yet watched our last video on RSHN, you should definitely check it out right after this video. You have seen this board in our previous video. This is the Delta board that we have used for the demo purposes. We have 5 of them printed, 2 of them still unpopulated, but here's the one that we have demoed. It is not without flaws, even though it surpasses expectations. The first problem that we have had, which is the LED strip connector, they don't have RGB, instead they have GRB. We had to flip the green and red wire in order to connect them. Second problem is none of these connectors that we have, this terminal block or these pin headers, these are all for industrial use cases. We need to do something about it. And not only that, there's also another major issues with this generation of boards, that is, there are these 5 capacitors. I thought these 5 capacitors would help smooth the flickering during the dimming. Not that it didn't do that, but it did that so well that the capacitors were practically holding on to the charge, and it was almost always 10 plus volts, which means the dimming wasn't really working properly. Now, usually these capacitors would work in favor of you while you're trying to stabilize the voltage or any power circuits, if that is what you're going for. But in this particular case, we are using pulse width modulation, PWM, switching the circuit back and forth very fast. So if the load downstream is not utilizing the power well enough, then the capacitors will hold on to the charge and the PWM will not really work because they will be held at a certain voltage, which is not ideal. So here's our new design with all the mistakes that we have identified have been fixed. Power stage, we have not made any changes fundamentally. We have just removed the bulk capacitor and we have added a normal DC battle jack. And in the power output section, as you can see, we have removed all the capacitors as they were unnecessary. In fact, after removing the capacitors from the previous boards, I got them to perform the way I wanted them to perform in the first place. We are not doing anything with our 3.3 volt power supply with the LDO. Even though this is more inefficient than a switching power supply, we are going to stick to this because overall it doesn't make much of a difference at this point. For our compute module, which is XIAO ESP32C6, we have had plenty GPIOs and we reordered them a little bit, and you will see how we have reordered the pins. Let's go check out the actual PCB so that it makes more sense. What we need to notice is that this is a barrel jack that we are using, so no longer a terminal block. We can just plug in a DC connector and that should power the board as well as the ESP32 module. Our decoupling capacitors are pretty minimal here, and that's pretty much all that is required. We don't actually need more than that. We went with SMD components this time on because the first with those through-hole components actually succeeded, and we want to level up our game and see how much we can optimize. So everything else pretty much the same. The MOSFETs are exactly the same. The value of the resistors for gate driving or even the draining, they are exactly the same. However, instead of using a through-hole resistors, now we are using 0402 or pretty small packaged resistors because we are built different. And while at it, we thought, why not add a couple of more features? So that's what we did. So here you can see the I/O connector, which you can use for general purpose input or output, but you can also use it for addressable LEDs. And that connector is right in the middle of all the different LED channels. It should be pretty convenient to use. While at it, we also added a neutral Y color option. That makes the white channels also have 3 distinct channels, cold, neutral, and warm, with its own voltage pin. So if we break out these pins, you are ready to attach a consumer LED right onto this board without any headache.
So now that we have our PCB design, it's the perfect time to talk about our sponsor, JLCPCB, the easy, affordable, and reliable place to order your PCBs. From easy EVA, just choose one-click order to upload your Gerber files, set preferences, and boom, an instant quote. and you're ready to place your order in seconds. You can get 1 to 8 layer PCBs for just $2 with lightning fast 24-hour production and strict in-house quality control to ensure your boards are always top-notch. With 2 decades of experience, 5 high-tech factories, and having helped over 6 million engineers worldwide, JLCPCB knows what they're doing. If you want to try it out, don't miss their special deal on 6-layer PCBs and get $30 off plus a free 2 micro-inch ENIC finish and 0 engineering fees for wire in pad. So if you're building your own hardware or you want to take your DIY project to the next level, check out JLCPCB.com by clicking the link in the description. You'll even get a $70 new user coupon just for signing up. Big thanks to JLCPCB for sponsoring this project and making this build possible. Now let's get back to the video.
So, look at them side by side. This is so much more portable. Actually, this is half the board size of the previous version that we have had before. And even if we ignore that part, look at the connectors, right? I can just take an off-the-shelf DC barrel jack and connect just like this. Whereas previously, I had to unscrew the terminal and put in naked wires right in here. Yes, it was more developer friendly, but it was not user friendly. And that's only for the power connectors. What about the LED connectors? This one connects off-the-shelf LEDs just like so. See? Whereas here, you had to solder all the wires separately for each of the channels. In this one, even though I soldered in the module right over here, that's not a problem at all because I can still program it whenever I need it because the USB is faced sideways. That was also not possible with this. Because of this LDO, I would be having a really hard challenge to program the microcontroller. Now, is this the end of the journey? No. But is this quite further away from this one? Hell yeah. So now that the board is complete, we need a light source to connect it to. I already had a portable RGB light lying around that stopped working a while back. So I popped it open to salvage the LED panel, but in the process, I found out that it only had a very small and very fixable issue. Once I took care of it, it just started working again. You can watch the extended cuts about nerdy little deep dives like this on our BreakerSpace Labs channel. Go give it some love. So I guess I gotta make up a light panel from scratch now. Let's open up a laptop. though this is more efficient than a switching power supply, we are going to stick to this because overall it doesn't make much of a difference at this point. Look, when I said using LDO doesn't make a difference, I meant it in an ideal world. But in the real world, you sometimes end up using fake parts that go up in flames the moment something is connected to it, along with whatever else is connected to it, and at that point, it's too late to ask for a refund for either of them. So, long story short, after 2 trials and fumes, I realized that this batch of LDOs are duds. So, I decided to go with an older, ancient, and much more potent dark magic, something that I've already used before. A step-down switching power supply or a buck converter. Instead of risking burning the ESP32 due to power failures on its sensitive 3.3 volt rails, I just powered it through its V-bus, which is much more lenient about the input voltage regulation. Just give it between 4 to 6 volts and that's it. It has way more sophisticated protection mechanisms and an internal buck converter to step it down to the required 3.3 volt itself. Now that I think of it, I should have been powering this through its V-bus pin all along. Well, at least we know how the inside of a XIAO module looks like. But for now, with this jugaad, let there be light. Alright, so this is how our setup looks like. Even though this room looks pretty dark, it actually is not. Here's my key light and here's the fill light, which you might also be able to see, which neither of them are dark. This is 50 watts, this is 25 watts. And in this light, I have had to reduce the analog gain of my camera in order to show exactly how well and how bright this light works. Also to demonstrate all the colors without affecting lights from the other sources. So with that out of the way, let's dive in. So right now, we have the light set up to warm tone of white. If you have watched the first video, then you can see the differences in our controller interface. We now have RGB and CCT sections split out instead of just plain 6 channels. Of course, we will also work with the RGB. So let me turn down CCT for that bit and go to RGB. Let's go a little bit of red, a little lot red, and the red max. Similarly, if I turn down the red and go a little bit of green, a bit more green, and a lot more green. Similarly, if we go blue, a little bit more blue, and a lot more blue. You can see a little bit of banding on the image here that I can see on my screen, but in real life, there is no banding. This color banding is just the HDR issue. The light is pretty bright and the camera cannot really resolve between that dynamic range. So that's why the banding appears. Now let's go back to seeing how else you can set colors. You can practically just choose the color like this and set it. Now we have a color picker. And that works with pretty much any other colors that you want to pick up and choose. And this input is browser dependent. So you might see different interface depending on which browser you're using. That doesn't matter. You can basically have an easier way to pick your colors, and that is super handy, I think. It automatically sets the channels, it automatically sends the request, sets the color, and I'm back to having the updated values on my screen, right? Now, let's turn off the red and green, and basically I have no lights whatsoever. Now we go to the CCT section, and in CCT, what we have now is also not only the channels, which of course you can set them individually, and try to adjust the channels with this slider instead. As you can see, I can go super warm white, and which sets the warm white channel to max and all the other neutral and cold white to 0. But then when you go a little bit toward the colder side, that is when the warm white is going down and the neutral white is ramping up, and it will continue. And as you can see, this is continuous. So you can basically just continuously change the colors and will immediately do that. This is I find interesting, very interesting. And at some point, it's actually 4000K. It actually sets the neutral white to the max and the warm white channel completely goes 0. So now you have neutral white taking over and completely blowing this scene out of proportion. And yeah, if I continue to go, it will reduce the neutral white channel and increase the cold white channel. But unfortunately, we don't have cold white channel on this board. I didn't put cold white LEDs on this panel because I couldn't source it properly. I think for the most part, up to 6500K, which is this neutral white goes up to, you can see it's kind of on the coldish side, which I'm okay with. So I didn't need more colder light for this particular panel, which I'm going to use. Of course, from the next video onwards, you'll see this panel in action. Now, let's go back to putting all the CCT control to 0 again and go back to RGB. And I really like this rainbow effect on the button. This is a quality of life feature that really gets me. I love it. The connecting mechanism hasn't really changed. You just type down the IP, and if the IP is not something that exists, then it will complain that it couldn't connect. Yeah, so that's pretty much it. So I will go back and connect to the one that I have here. And once you get connected, you'll get all the updated values and you can go ahead and change them however you like. This one was comparatively more comprehensive, I believe. A lot of you complained in the last video what I showed on the floor with the dual lightsaber, that there's no reference for the color values, so it just looked like a light show and not really a demonstration of how the lights function. So I hope in this context, the light looks a little bit better for keeping a reference of what it is supposed to look like versus what it does look like. And if you have any question or comments on this, please go ahead and ask. I'd be happy to answer.